Um, all right. So, welcome everybody. I'm so glad to see you. And it is such a weird semester that we're dealing with just now. And I don't know what to make of what we're all going through. Um, usually when something crazy happens, I can say to young people, oh yeah, that's like something that happened when I was a kid. And, remember back in 1968, it was like that. But now, no, actually, this is as new for me as it is for you. So I can't say what's happening. But we will do what we can to get through it together. So, for now, welcome to this class. And let me just tell you a little bit about the purpose here. So this is a class about the statistical mechanics of soft matter. And of course, with the big emphasis on liquid crystals, that's a big part of what we do here at Kent State. One thing that I love about soft matter science or liquid crystal science is how you can look at the same things from so many different points of view. And so here in Kent State, we have a lot of faculty who think about liquid crystal science, but starting from different perspectives, right? And so you'll have people like Professor Torsten Hegman, who will tell you that liquid crystal science is a branch of chemistry, right? That is his point of view on it. And he teaches a class where he tries to persuade you of that, right? But then you'll have other people who will tell you how liquid crystal science is basically a branch of optics, or a branch of electrical engineering, because that's the kind of thing that they do with these materials. And so, I'm here to tell you about how liquid crystal science is really a branch of theoretical physics, and how it's connected to the theoretical physics that you might hear about in classes about quantum mechanics or whatever subjects. And so, we on the faculty are going to expose you to lots of different points of view on this kind of a subject. And hopefully you will find at least one point of view that you love and that you really want to concentrate on in your own personal research work. And then with other points of view, maybe you won't love all of them. That's okay. You don't have to love everything. But you can at least learn to appreciate some of the other points of view, and you can learn from them. You can see what insights they provide that you can use in your own research. And you'll be prepared to talk with people who have different kinds of specialties. And so, there are lots of scientific collaborations that include people with very different backgrounds. And it's good if you at least speak a little bit of the language of people from other kinds of backgrounds so that you can communicate with them. That's all to your benefit going forward in your careers. All right, so, what is my point of view, right? So with the point of view that I'm going to be teaching you through this semester, the idea is that we think about symmetry, right? We characterize different kinds of phases of materials by saying what sorts of symmetry do they have? What sorts of symmetries have been broken? And so what kinds of order are there in the phases? And then we think about what kinds of mathematical objects do we need to characterize the order, right? And so our goal is to find the right kind of mathematical object that goes with whatever property of materials we're trying to describe. And then we get to a kind of abstract view of the world where we think, oh, the world is made of these mathematical objects, right? And so we're not necessarily talking about the world made of atoms and molecules, but the world where there is the right kind of order parameter, the right kind of mathematical object at every position inside of a material. So, that's the kind of perspective that I'm going to be presenting to you this semester. And I realize I'm speaking in kind of an abstract way, and I'm going to be showing you lots of specific examples as we go along through the semester. That's the goal, right? That's what I'm going to try to be presenting to you in this course. To tell you a little bit about my background, I got a PhD back in 1989 from Harvard. My advisor was David Nelson there. So I was enrolled, in a physics PhD program there. It wasn't specifically related to liquid crystals. My own dissertation research was mostly related to liquid crystals, also some to metallic glasses. And after I finished the PhD, I did a postdoc at UCLA, the University of California in Los Angeles, and also part-time at Caltech. And then after 3 years in Los Angeles, I moved to a position at the Naval Research Lab in Washington, D.C. So the Naval Research Lab, NRL, that's the main lab for the US Navy. The Navy actually has many labs, but this is kind of the central general purpose one. I was there doing theoretical physics research related to materials that would be of use for the Navy in lots of different ways. Partly liquid crystals, partly lipids or other organic materials. So I was there for 13 years. So that's a big piece of my career. And then in 2005, I had an opportunity to move to Kent State. They were creating then a senior faculty position in liquid crystal theory, and I was very fortunate to get that position. I moved out here together with my wife, Robin Sellinger, whom some of you have met, others I'm sure will be meeting over the course of your research. That was a nice transition for me from a government job into a faculty position. But I'm glad to have had experiences in both kinds of work, in government work and academic work. Over the course of the semester and beyond, I'd be glad to talk with any of you about, your kinds of career goals and what kinds of job opportunities you might be interested in for after your PhD. That's a little bit of background information about me. I guess I'd like to ask you all to introduce yourselves a little bit. I'd like to just learn about who's out there. So let me pause the recording. You don't need to be recorded for doing All right, recording back on. For a few practical things with the Zoom. Well, first I should ask, can you guys all hear me reasonably well? Or do I need to do anything to work on my microphone or my video or anything like that?
No, yours is the best connection I've seen so far over these online things.
Okay, good, good. If there are Zoom problems in the future, you've got to speak up and tell me, because I won't know unless you tell me. Okay, and so if you have trouble hearing me or seeing any of the things that I'm writing, and I'm going to be writing on a whiteboard and showing PDFs and stuff like that, right? So if any of that doesn't work, please speak up right away, because otherwise I'll just have no idea and I'll keep doing the wrong thing. Okay. I guess one other request is I think I would like it if you keep your video on most of the time, because that helps me to remember that there are real live students out there and I'm not just talking to myself. And so I certainly would understand if you need to turn your video off for a little while if you're going to the bathroom or whatever you're doing, but then turn it back on afterwards. And then you know, it just makes me feel more like I'm speaking to real people. You know, I don't hear much of a problem with noise. If you are in a place where there is noise because of somebody working on the street or mowing the lawn or something like that outside your window, then please mute your microphone. But by all means, if you want to ever ask anything, please ask. And so just unmute your microphone and say, excuse me, I have a question, or whatever you want to say, right? And I mean, you can also raise your hand and hopefully I'll notice that you're raising your hand. But if I don't, then speak up because I want to hear from you. All right. So let's do some practical things. Okay, so it's my job at the beginning of the semester to go over the syllabus. So I emailed that to you, but let me share it on my screen and then we can just talk about whatever might be important here. So does it work? Did you see it?
Yes.
Yes, you do see a syllabus on your screen. Good. Okay. So, where am I? Okay. So, just to go over the basic information, we have classes on Zoom with this link. You all figured it out. Good job. All right. Now, for other contact information, there is my office number, but I'm never there, so don't expect to find me there this semester. So too bad, because it's a nice office too. My office phone, but I'm not there to answer it. I do have my mobile phone number, so you can call that or you can send me email. I'm supposed to list office hours, that is when I'm available to meet with you. I was planning that I'll just be available after the class just to continue any discussions that you might have on the same Zoom connection. So that's good for me if it's good for you. But if that doesn't work for you, if you want to meet at another time, just send me email and we can work something out. Okay, so there is the official description of the class. And this is the kind of subject I was trying to get at in the beginning of this this class, that I'm going to be teaching you about order, disorder, and phase transitions in soft matter. And so there's this range of topics. And so I list, magnets, gases, liquids, crystalline and amorphous solids, and liquid crystals. And so it's a sequence of topics which is designed to introduce the theoretical ideas one at a time. And so I want to lead up to liquid crystals. Right? So the last 1/3 of the semester or so is devoted to liquid crystals. But I'm trying to introduce each of the important areas in the simplest possible context. And so that's how I picked the sequence of topics there. So hopefully that will work out for all of you. The learning outcomes, these are the things that you're all supposed to be able to do by the end of the semester. That is my goal. Do you see the mouse moving around, by the way, that points at things? Okay, good, thank you. So I have this book that I wrote, which is a textbook for the class. It's a real book, look, a real book. But you are not supposed to pay money for it. Okay, it is supposed to be available for all of you for free with a Kent State site license. And so you are supposed to be able to go to the links that I provide. Okay, so the first link, that is something on the publisher's website, which works when you are on campus in a Kent State computer. Okay, or with a Kent State IP address. The second link is the Kent State proxy server. So if you are off campus, you are supposed to be able to click on that link, and then it will bring up a login page where you can log in with your Kent State username and password, and then it forwards you to the publisher's website with the authorization, and then you can download the book. Have any of you attempted to download it so far? Yes. And it worked? Did anybody have trouble? Okay.
Just me, it only loads the very first page of the textbook, and then the rest of it's all blank.
Mine does that too off campus. But if you download the individual chapters off campus, it works. Or go on campus and download the whole textbook.
Okay.
I also have it on a flash drive if you need it.
Thank you.
Some of you might be thinking to yourselves, why does this crazy professor ask us to download the book? Why doesn't he just send us the PDF for the book? The answer is that if you download it from the publisher's website, it makes me look good to the publisher, that it helps my statistics. I don't get paid extra money by the publisher, but I look good so that if I ever want to write another book, they know that people are downloading this thing. And so that's why it's helpful for me if you each individually download it, if it works. But if it doesn't work, you don't have to bash your head against the wall to try to make it work. Then either I can send it to you, or Corinne can send it to you, or somebody can send it to you. That'll be okay. All right, on the next page, I listed a couple of other books as recommended. So these are books that cover subjects related to this course. The first of those is by Professor Lavrentovich from Kent State, from AMLCI, along with his longtime collaborator, Maurice Clément. I would say that book is maybe a little bit more advanced than what I'm teaching here. It's really a lot of information, especially related to defects in liquid crystals, which is a subject on which Clément and Lavrentovich are pretty much the two experts of the world. That is, I think, maybe a more advanced resource if you want to get into subjects in more depth. The other one, the Richard Jones Soft Condensed Matter, that's a book that I used to use as a textbook before I wrote my own. I would say it's less theoretical than mine. It's more of a survey of different materials, at the level of an undergraduate material science major. It really has a lot of information presented in a pretty compact way. It's a good survey from that point of view. These books are not available as legal free ebooks as far as I know. As far as I know, you have to get them from the library or pay money for them. But there may be things that I don't know about. Okay, so about online resources. So you all are here on Zoom. You know about that. So I was encouraging people to use a computer or a tablet because once I start writing equations, they're just hard to read on a phone screen. And so I hope you all have something bigger than a phone screen to look with. Then I'm also using this system, a website for the course called Blackboard. Have you guys logged into that so far? Do any of you know what I'm talking about? Yes. Is there anybody who has no idea what I'm talking about? I see some looks that look like they don't know, even if nobody's actually making a gesture. Okay. Kent State has a system for course management, which is like making a website for each course. Okay, and Kent State undergraduates use it a lot. Kent State graduate students, not so much. But it is at least a place to put information that I want to share with you guys. So I will be posting videos and PDFs and other kinds of files related to the course. I will also be posting homework assignments, things like that. This is a system that has a certain amount of security associated with it, so that when I grade your homework, I can put in the grades and you can see your own grades and you can't see other people's grades. Please try to log into that, okay? And it's not that hard. If you just click on that website and log in with your Kent State username and password, then you should be able to find this course from your list of courses And there isn't very much up there yet, but there will be things posted there. And so you should figure out how to log into that. If there's any trouble, just let me know. All right, for other information, okay, concerning math, in general, the math level for this course and the math level for liquid crystal physics in general is multivariable calculus. So, you know, you're expected to be familiar with things like partial derivatives and multiple integrals, and with derivative operators like the gradient, curl, divergence. Those kinds of things are used in liquid crystal physics all the time. Now, there are a couple of more advanced math topics that I'm going to be teaching during this semester. Those things are variational calculus and tensors. So these are things that, you know, some students have seen in their undergraduate work, others have not. So I'm not going to assume that you know these things. I'm going to teach them and then apply them to physics problems. So those things will be coming over the course of the semester. Now, concerning software, there's a kind of software that I really love. I mean, the students who've had classes with me know how much I love this. It's called Mathematica. So this is software that is meant for doing mathematical calculations, not just with numbers, but it knows about derivatives and integrals and all kinds of symbolic manipulation also. So I'm going to be using it in the class. And so I will do some demonstrations for you. And then afterwards, I will post the Mathematica files on this Blackboard website. So I would like you guys to install Mathematica on your computers so that you can run my software, and you know, you don't have to create Mathematica files from scratch, but you can make little modifications to mine and see what happens. I think it's fantastic. I think it's wonderful to learn, and it's free for you to install while you're at Kent State. And so you might want to learn it. You might learn to love it as much as I do. Well, nobody loves it as much as I do, but you might learn to love it some. And so, yeah, so there's a link which has instructions about how to install it. And if you follow the instructions for student personally owned machines, I think it will work. If you have problems, let me know. The installation instructions are actually surprisingly complicated. The licensing stuff is more complicated than you would expect. And so you have to really read the directions carefully and follow things step by step, but it will probably work. Now, when I give homework later on in the semester, I will sometimes ask you to make graphs. Okay. Now that you are graduate students, when you make a graph, that normally means making a graph with a computer, okay? And so you're kind of past the point of just drawing things on graph paper, okay? And so, you know, I will expect you to make graphs with computers. That can be with Mathematica if you want. It doesn't have to be. It could be as simple as just using Excel, if that's what you're familiar with. But you know, something with some kind of computer graphs. Okay, and let's see, what else can I say? units. Get the right units, okay? So, you know, I trust whatever undergraduate programs you've been through have taught you something about units for physics or chemistry, right? And that actually matters, okay? And so I do expect you to get the right units, and I will, you know, give you an electric shock or something if you don't, and then try to learn to do it. Concerning grading, here is the plan for grading. I made up percentages of 20% on homework, 20% on the midterm exam, 45% on the final exam, and 15% on class participation. So, you know, I do expect people to interact some in the classes, that you can ask me questions or I can ask you questions or something like that, but to have some level of interaction in the class, and that keeps it from being too boring. For me, I don't care if it's boring for you, but I don't want it to be boring for me. All right. And for the midterm and final exam, I picked dates for those things. Assuming that we are still kind of in quarantine all through the semester, these exams will be 24-hour exams for you to work on at home, and then send me your test papers at the end. I am not going to be watching you over the monitor during 24 hours while you work on it. I think you're graduate students of physics or material science now, and I have to be able to trust you with that, as I trust you when you're doing your experiments. Okay, so that is the plan for grading. I made up a tentative schedule of classes here. I will attempt to stick with this schedule. I don't know if I'll get it exactly right, but I'll try. There are various official statements from Kent State, which I'm sure you've seen from all your other classes, and I'm showing you again for this class. I don't have a lot to say about those things. Actually, I do have one thing to say about those things, and that is concerning homework. Different professors may have different expectations for how you work on homework. And let me tell you my personal expectations, which don't necessarily apply to other professors, okay? From my own point of view, I would like it if you talk with other students when you are doing the homework, okay? I would like it if you communicate with each other, as long as you don't transmit viruses back and forth between each other, okay? But I would like it if you communicate with each other in some healthy, safe way. You know, it's really my dream that you should be talking about my class, even when I'm not present. I don't know how much that happens in real life, but it's my fantasy that you should want to talk about my class. And so please do so, okay? Please do talk about the homework. The one thing I would say is, you know, after you talk about it, after you figure out what the answers are, you should sit down by yourself and write the answers on the paper, okay? And so I would like it, you know, if each answer is written by the student individually, not just to make a copy of the answer from one person to another, okay? Yes, you are allowed and encouraged to communicate about the homework. That is not true for the tests. With the tests, you are not allowed to communicate with other students. Okay, good on that? And I know for international students, there are sometimes, different cultures and different expectations for the style of work and for what amount of cooperation is allowed or not allowed. And so there have been times in the past when that has come up as an issue with students from other countries. And sometimes there really have been a difference in expectations between what we think and what the student might have been accustomed to. And so for our international students, I will just say, you have to ask about that sort of thing. And whenever you're uncertain, you should feel free to ask me or ask whatever professor you're working with. And professors will answer that sort of question, and we'll just try to be straightforward with you about what's allowed or not allowed. And so, you can save yourself some trouble by asking that way. Are there any questions so far about things on this syllabus?
About our homework and tasks, do we always submit them via the Blackboard or via email for this course?
I don't know. I'm a little bit new at this business of online instruction. And so I have never actually seen students submit homework by Blackboard. I guess it's possible. Chris, I'll put you on the spot because you were an undergraduate at Kent State. So maybe you know about these things. Is there a system for submitting homework on Blackboard?
Yes, but I'm pretty sure it needs to be set up by a professor on a case-to-case basis. Like, it's not just there on Blackboard. You have to set it up.
I'll look into it. But,
yeah.
And if I can, I will. But if not, then we'll just say email. Okay, fine. I'm nearly out of time. I just want to practice one thing in the last 1 minute or so of the class. I want to practice my whiteboard writing system to make sure that it works for you. And then after that, I'll stop for today. Okay. So let me practice it. So I've been trying all summer getting ready for this moment. So let me see if this is really going to work. Okay, so let's see. I go to share screen and I say iPad. And so now I go to my iPad. Now I go to my iPad and I do screen mirroring to zoom like this. Okay, so now do you see a big yellow thing? You can see me writing on it, I think. But the trouble is now that covered up all your faces, so I can't see if you guys are all nodding. Okay, so now, oh, I got your faces back. Good. So yes, did you see me writing something?
Yes.
You did. It works. Oh, this is so cool. That is great. And I even have a laser pointer. Ooh, can you see my laser pointer moving around?
No.
No laser pointer. Oh, bummer. What about now? Does that work as a laser pointer?
No, I think it only works for once it's actually on the page instead of a cursor.
Okay, let me see if I can write new things. Do you see me writing more stuff now?
No.
Darn it, this is the same problem that I had with Chang yesterday when I was practicing this, which is that when I covered up your...
we are seeing.
Oh, now you see it.
I think it takes a sec to load, maybe.
No,
It just
I
doesn't
think-
do it in
I
real
think
time.
that when I have the window with your faces covering the window with the writing on my computer screen, then the window with the writing doesn't get shared out there.
Yeah.
I
It has
think
to be the active tab.
that's it. It has to be the active tab. Okay, now do you see my laser pointer?
Yes.
Yes, you do. Okay, well, this is all good to know. So I will know to keep it uncovered on my screen, and then hopefully it will be visible to you guys. Okay, but again, if anytime I say I'm writing something, but you don't actually see me writing something, speak up, okay? And then maybe something's going wrong. Okay, so that wraps things up for today, okay? So my plan then is to talk on Monday about the first chapter of this book, which is quite short. So I'm going to say, read chapter 1. You could see that, right?
Yes.
Okay. Read chapter 1, which is quite short. Okay. And chapter 1 is sort of a funny, silly little example that I made up, which is meant to illustrate the point of what is a free energy and why should we care about a free energy? Because that's the basis of so much of what I'm going to be doing later on in the semester. So we'll talk about chapter 1 on Monday. And as I said again, it's kind of a little joke sort of example. And then we'll get into real physics examples with chapter 2 on Wednesday of next week. Okay, so have a good weekend, all of you, and I will, I'll see you on Monday over the Zoom. And if any of you have more things you want to talk about, just stick around on the Zoom and we'll talk about those things.
Thank you.
Okay, goodbye, everyone.
Thanks. Have a good weekend.
Bye-bye.
Thank you.